learn singular value decomposition, okay, SVD technique in this video. Now why exactly singular value decomposition method is being used? I hope till now in my previous videos we have found eigenvalues and eigenvectors for a square matrix. Okay, a square matrix means always for a square matrix the m and n value will always be equal, means the number of columns will be equal to number of rows. So till now we have worked on the square matrices. Now how to find out the eigenvalues or eigenvectors for a rectangular matrix? So that is what the singular value decomposition is helpful for. You find out the eigenvalues of a rectangular matrix when the number of rows is not equal to the number of columns dimension. Okay, so therefore by using singular value decomposition we can factorize the given rectangular matrix into U sigma into V transpose, U sigma into V transpose, where U and V are two different orthogonal eigenvector matrix which are being found by A transpose into A. If you do, we will find out the eigenvectors which we find out with that A transpose A are the eigenvectors which are V, whereas we find out the eigenvectors U by considering A into A transpose. Okay, so we take A transpose into A and find out the eigenvectors, and that we will get V is the vector that we get, whereas when we find the eigenvectors by considering A into A transpose, then we will be end up in getting the eigenvectors U. Okay, now we do have a sigma in between U and V transpose which is a diagonal singular values. So this diagonal values are being found by considering the square root of the eigenvalues that we get in the problem. Okay, by considering the eigenvalues that we get from in the problem. Okay, so square root of eigenvalues. So we write the diagonal matrix like how we wrote in the square matrix earlier in diagonalization process. In the same way we try to write the diagonal elements even in this particular problem also, but while writing the diagonal elements we try to put the square root of those eigenvalues in the diagonal entries. Okay, so that is what we do in singular value decomposition. Anyway, we will take one problem, we will take one matrix, and then we will see how to apply this method singular value decomposition for that particular matrix, and then we will see how to calculate the U vector which is eigenvector U. We will also see the steps involved in finding out the V vector, and then we will see how to obtain sigma, and then we will see how to combine these three together to write write the final answer that A can be factorized with U sigma and V transpose. So let us take one small problem for this. Now let us take these two examples and let us see how to apply the single value decomposition to solve the problem. So first I will take matrix A equals 1 2 2 1, A equals 1 2 2 1. So step by step we will do. First we need to find out A transpose A to find out V, and then A into A transpose to find out U. So I will first find out U to find, so that is the first step, to find U. So just watch carefully and you also can practice while I am doing in the video. So A into A transpose is what we need to find out, which is equal to A is what, 1 2 2 1, whereas A transpose is equal to 1 2 2 1. Okay, so 1 2 2 1, 1 2 2 1. So now when we multiply these two, what do we get? 1 into 1 plus 2 into 2 is 4, 1 into 2 plus 2 into 1 is 2, 2 into 1 is 2 plus 2 into 1 is 2, 1 into 2 is 2 plus 2 into 1 is 2. Okay, let me check once again. 1 into 1 plus 2 into 2 is 4, 1 into 2 plus 2 into 1 is 2, 2 into 1 is 2 plus 1 into 2 is 2, 2 into 2, okay, sorry, 2 into 2 is 4 plus 1 into 1 is 1. So which is equal to 5, 4, 4 and 5. 5, 4 and 4 and 5. Now what we should do to find out u, we need to consider A into A transpose minus lambda I equals 0 to find out the eigenvector first. So eigenvalues. First we will find out what is eigenvalues for this A into A transpose. Based on those eigenvalues we find out eigenvectors, and by taking the Gram-Schmidt processing we will see how to write the vector u. Okay. So first we will find out the eigenvalues. Now A into A transpose minus lambda is what? I will just directly write, which is 5 minus lambda, 4, 4 and 5 minus lambda, which is equal to 0. So it is 5 minus lambda the whole square minus 16 equals 0. So here 25 plus lambda square minus 10 lambda. So a square plus b square minus 2ab, that is what the formula, minus 16 equals 0. Therefore lambda square minus 10 lambda, 25 minus 16. Okay, so 15 minus 6. So I will get 9 is the answer. So 25 minus 16 is 9 is the answer. Now I can split up this 10 into 9 and 1. Therefore I will get lambda square minus 9 lambda plus 9 equals 0. So if I take lambda common here, I will get lambda minus 9 minus 1 if I take lambda minus 9, which is equal to 0. Therefore lambda minus 1 into lambda minus 9 equals 0. So finally I will get lambda to be equal to 1 and lambda to be equal to 9. So these are the two values of eigenvalues that I have got for A into A transpose. Now what I will do, I will try to find out the eigenvectors for A into A transpose, A into A transpose. So first thing is when lambda equals 1. So what is A into A transpose minus lambda I? You go back to that. So it is 5 minus lambda, 4 and 5 minus lambda. So therefore it is A into A transpose minus lambda I into x. So into u I will write now because we are finding out u in this, equals 0. Okay, so therefore here it is 5 minus lambda. So 5 minus 1 is 4. 5 minus lambda, which is 5 minus 1 is 4. Then 4, 4. Then 4, 4. Again 5 minus 1 is again 4. Multiplied by u1, u2 equals 0. Therefore it is 4u1 plus 4u2 equals 0. Similarly 4u1 plus 4u2, both equations are same. Therefore I can easily say that in these two equations I can say u1 or u2 equals minus u1. u2 equals minus u1. Now if I take u1 to be equal to 1, so if I take u1 to be equal to 1, then I will get u2 to be equal to minus 1. So therefore this is the first matrix which we have got 1 and minus 1. Now let me go with lambda equals 9 now. Okay, so this is for lambda equals 1. Now I will go for lambda equals 9. So 5 minus lambda again. So what is that? 5 minus 9 is minus 4. This is 4. This is 4. 5 minus lambda, which is 5 minus 9 again, minus 4. Into u1, u2 equals 0. So here what I will get? Minus 4 u1 plus 4 u2 equals 0. And second equation is 4 u1 minus 4 u2 equals 0. So with these two equations I can easily say u1 equals u2. So when I say u2 equals 1, then u1 is also equal to 1. So the second vector which we have got here is 1 and 1. Now to find the final, to write the final matrix U, to get the final matrix U, to get my final matrix, eigenvector matrix U, we use Gram-Schmidt process. So what Gram-Schmidt process says here, you take the distance of u1 and u2, means you take the norm of u1 and u2. So it is nothing but root of 1 square plus minus 1 the whole square, which is equal to root 2. Here u2 also get the same norm here. If you see 1 square plus 1 square, which is again equal to root 2. It is nothing but what is norm? Norm of u1 where norm of u2, which we did now. So you got root 2 and root 2. Therefore, the final matrix U will be equal to, you are going to divide this norm by the vectors. So first vector is 1 and minus 1, 1 by root 2, then minus 1 by root 2, minus 1 by root 2. Second vector is U2, which is 1 and 1. So I will say 1 by root 2 and 1 by root 2. So this is my matrix U in the process. Okay, this is my matrix U in the singular value decomposition. Whatever we need to get matrix U is all about. Then we will see how to find out the matrix V. Okay, so we have found U. Now let us find V. Okay, to find V now. Okay, so to find V, what we need here is, so to find U we took A into A transpose. Now to find V, we will take A transpose into A is what we need to take for finding V. So therefore we will see what is A transpose into A now, which is equal to, so what was A transpose? Let us see that first. So here A is 1 2 2 1. So A transpose is again 1 2 2 1. So it is same thing what we get, 1 2 2 1 into 1 2 2 1. So you will end up in getting even the V eigenvalues for V and eigenvectors for V, you will end up in getting the same values. So here whatever the eigenvalues that we have got here, you get same because it is a symmetric matrix and it's also a square matrix. Therefore you will end up in getting same lambda values, like lambda equals 1 and lambda equals 9, because A transpose into A is one at the same. So here while finding out the V vector, A transpose into A will end up in getting the same value what we have got even while finding out U vector for this particular problem, because the given matrix is a symmetric matrix and the A transpose is equal to A. So either you do A transpose into A or A into A transpose, the solution will be same. Therefore lambda will be equal to 1 and lambda will be equal to 9, and similarly the vector will also be equal to U vector, whatever we find out will also be equal to whatever the U vector that we have found was what do we say, like 1 by root 2 and 1 by root 2. So whatever we have found is 1 by root 2 and whatever we had that. So here there is one changes here now. Anyway, I will not write U, I will just write V here. So V is equal to, same thing we get as U, which is 1 minus 1 1 and 1 was that, without the Gram-Smith processing I am telling you. Now I need to find out V transpose. So V transpose is what we need to find out, which is equal to 1 minus 1 1 and 1. Finally the V transpose that we take is based on the distance that we get by taking the norm of this row wise norm what we take. Okay, so this 1 and minus 1 will be equal to square root of 2 again. This 1 and 1 will again be square root of 2. Now this will be the final V transpose which we take, 1 by root 2, which is Gram-Smith processing whatever we are doing here, minus 1 by root 2, then again 1 by root 2 and then 1 by root 2. Now this is what V transpose is. This is what V transpose that we get. as it is a symmetric matrix, so I end up in having the same values what I have got in U, but the final step what we took is V transpose, and for that we took distance, means norm, and then we took that V transpose where each element will be divided by the norm that we take for that particular elements. Now to find sigma, as I told you, sigma is a diagonal matrix, so sigma will be now 2 cross 2 diagonal elements. See, d1, d2, 0, 0. This is what sigma. Now what is d1 and d2? It is the square root of the eigenvalues. Therefore sigma would be equal to square root of 1 is 1, 0, 0, square root of 9 is 3. Square root of 9 is 3. Okay, so this is equal to, I'll just write square root of 1, 0, 0, square root of 9. And finally we'll end up in getting sigma to be equal to 1, 0, 0, 3. So therefore A, matrix A equals U is what? U is 1 by root 2, 1 by root 2. U is 1 by root 2, 1 by root 2, minus 1 by root 2 and 1 by root 2 multiplied by sigma, because we know that A equals U sigma V transpose, so multiply by sigma, which is 1, 0, 0, 3, and this will be multiplied by V transpose, which is V transpose is 1 by root 2, 1 by root 2, 1 by root 2, 1 by root 2, and then minus 1 by root 2 and 1 by root 2, minus 1 by root 2 and 1 by root 2. So this is the solution for this particular problem, which is singular value decomposition. Now if you multiply these three values, you can do it in using your calculator. If you multiply these three values, you will end up in getting the matrix 1, 2, 2, 1. Okay, so 1, 2, 2, 1. So fine. Now let us go with the second example. 4, 0, 3 and minus 5. So let us take second example. A equals 4, 0, 3 and minus 5. So 4, 0, 3 and minus 5. So let us take this example and let us see how to solve the problem. So as usual, to find out V, we take A transpose into A to minus lambda I into V. Now to find out U, you take A into A transpose minus lambda I into U, which is equal to 0. This is also equal to 0. This is what we do. So before that we need to find out the eigenvectors, eigenvalues and then vectors. Okay, so let me first take U, where we find out A into A transpose. So here it is equal to 4, 3, 0, minus 5 is A, whereas A transpose is 4, 3, 0, minus 5. Now A and A transpose are not equal, therefore it is not symmetric matrix. Now 4 into 4 is 16, plus 0 into 0 is 0. Okay, 4 3s are 12, plus 0 into minus 5 is 0. 3 into 4, which is 12, minus 5 into 0 is 0. 3 into 3 is 9, 9 plus 25, because minus into minus plus. So 9 plus 25 would be 34. So we got 16, 12, 12 and 34 is the thing which we have got, which is A into A transpose. Now to find out U, first of all we'll take A into A transpose minus lambda I to be equal to 0. So we take the determinant of this. So therefore I'll be getting 16 minus lambda, 12, 12, 34 minus lambda equals 0. Now if I try to find out what is the solution for this, 16 minus lambda into 34 minus lambda minus 12 into 12, which is equal to 0. Now we will try to factorize these things. So let us factorize these things. So 16 into 34 is 544 minus 34 lambda minus 16 lambda plus lambda square minus 12 into 12 is 144 equals 0. Therefore, lambda square minus 50 lambda plus 544 minus 144 is 400 equals 0. Now, if I find out the root for this particular equation, I will be getting one root. I will get lambda 1 to be equal to 10, whereas lambda 2 to be equal to 40. So these are the two lambdas that I have got by taking A into A transpose. Now let us find out the vectors, eigenvectors, which is nothing but U. So to find eigenvectors, first I will take the condition for lambda 1, which is 10. So here A into A transpose minus lambda, 16 minus lambda 12, 12. So I have got 16 minus lambda 12, 12, 34 minus lambda into U1, U2 equals 0. Now lambda is 10, therefore 16 minus 10 into 6, 12, 12, 34 minus 10 is 24 into U1, U2 equals 0. So therefore 6 into U1 plus 12 into U2 equals 0. 12 U1 plus 24 U2 equals 0. I will divide this first equation by 6. I will get U1 plus 2 U2 equals 0. Whereas second equation I will divide it by 12. I will get U1 plus 2 U2 equals 0. So both are equations same. Therefore U1 would be equal to minus 2 times U2. Now if U2 equals 1, then U1 will be equal to minus 2. If U2 equals 1, U1 will be equal to minus 2. So therefore the first vector U1 would be equal to minus 2 and 1. Minus 2 and 1. Now let me take the vector when lambda 2, which is equal to 40. Let me take the condition when it is 40. So it is 16 minus 40, right? 16 minus 40 would be equal to minus 24, and this is 12, 12, and 34 minus 40 is minus 6 into U1, U2 equals 0. Therefore, it is minus 24 times U1 plus 12 times U2 equals 0 is the first equation. 12 times U1 minus 6 times U2 equals 0 is the second equation. I will divide both the first equation by 12. I will get minus 2 times U1 plus U2 equals 0. I will divide the second equation by 6. I will get 2U1 minus U2 equals 0. Therefore, in both the equations you see, I will get U2 to be equal to 2 times U1. Now, if I substitute U1 equals 1, then I will get U2 to be equal to 2. Therefore, the second vector U2 equals 1 and 2. 1 and 2. Now let me find the Gram-Schmidt processing here to find out the distance. So it is square root of a square, which is 2 square, minus 2 square plus 1 square, 2 square is 4 plus 1, which is 5. Similarly, here also you get square root of 5, which is equal to norm of u1, and this is norm of u2. Therefore, finally, the matrix U equals the first vector is minus 2 by root 5, 1 by root 5, minus 2 by root 5, and 1 by root 5, and the second vector is 1 by root 5, 2 by root 5. So this is the matrix U. Okay, now let me find V. Let us find V. To find V transpose for the same problem. So to find out V, we need to take A transpose into A, which is equal to, so let me see what is A transpose, which we did earlier. A transpose is 430 minus 5, 430. So the A transpose is actually 430 minus 5, 430 and minus 5 multiplied by 403 and minus 5. So this was the question. If I am not wrong, let me just check it off. Whatever the question, which is 403 minus 5. Okay. So therefore, we'll multiply this. 4 4s are 16 plus 3 3s are 9. 16 plus 9 is 25. Then 4 zeros are 0. Minus 5 3s are 15. 4 zeros are 0. Minus 5 into 3 is minus 15. And then 0 into 0 0 minus 5 into 5 is plus 25. So this is what A transpose into A. Now let us find out the eigenvectors for this. So it is the determinant of A transpose into A minus lambda I, which will be equal to 25 minus lambda minus 15 minus 15, 25 minus lambda. So which is equal to 25 minus lambda into 25 minus lambda minus 15 into 15. So here if we solve this equation, so what do we get here is 625 minus, so it is 625 minus 25 lambda minus 25 lambda plus lambda square minus 15 into 15, which is 225. Minus into minus plus, so minus 225 here, which is equal to 0. So which is equal to lambda square minus 50 lambda, 625 minus 225, 625 minus 225 is 400 equals 0. Now if you look back and see what are the roots that we got for U, you will end up in getting the same roots for even V while calculating. See, lambda square minus 50 lambda plus 400. So therefore, even here also we are getting the same lambda square minus 50 lambda plus 400. Therefore, if you find out the root, we will get the same roots where lambda 1 equals 10 and lambda 2 would be equal to 40. So we got the same roots. Now let us find out the vectors. So when lambda 1 equals 10, what would be the vector? We'll see. So it is A transpose into A minus lambda, which is 25 minus lambda and minus 15 minus 15. again it is 25 minus lambda multiplied by v1 v2 equals 0. So here let me take first condition 10. So if I will get 25 minus 10 is 15 minus 15 minus 15 again 25 minus 10 which is 15 into u v1 v2 equals 0. Therefore equals 0. Therefore it is 15 v1 minus 15 v2 equals 0, first equation. So I would say v1 equals v2 because 15 gets cancelled. Similarly minus 15 v1 plus 15 times v2 equals 0. Again we will end up in getting v1 equals v2. Now here when v1 equals 1, v2 is also equal to 1. Therefore the first vector v what we get is 1 and 1. Now let us go on finding the second vector when lambda 2 is 40. So 10 and 40 are the two roots. So therefore 25 minus 40 is what first thing. So 25 minus 40 will be minus 15. Minus 15 minus 15. Again 25 minus 40 is minus 15. Into v1 v2 equals 0. Therefore I'll say minus 15 times v1 minus 15 times v2 equals 0. Therefore it is v1 equals minus v2. Similarly minus 15 v1 second equation is also same. Therefore again I'll get v1 to be equal to minus v2. So when I say v2 equals 1, then v1 will be equal to minus 1. So therefore the second root v2 will be equal to minus 1 and 1. Therefore the total vector v matrix would be 1 and 1 minus 1 and 1. V transpose equals 1 1 minus 1 and 1. Now you take the norm of the row vectors whatever we have. So this becomes square root of 2 because square root of 1 square plus 1 square is square root of 2. Even this becomes square root of minus 1 the whole square plus 1 square, again it is square root of 2. So therefore the total v will now be equal to 1 by root 2, again 1 by root 2 minus 1 by root 2 and 1 by root 2. So we got both u and v matrix. So we got this is v transpose. So we got both u and v matrix for this particular problem. Now we are left out in finding out sigma here. So what would be sigma equals? Sigma is, we know the two roots lambda is 10 and 40 in both sides. So normally you get roots to be same in both v and u. Okay, so the roots will be same in both v and u. So sigma would be equal to square root of 10, 0, 0 and square root of 40. You can either solve it or you can keep just square root of 10 and square root of 40. So therefore the matrix A equals u into sigma into v transpose. So which is equal to u is, we have solved already for u, what we have got, minus 2 by root 5, 1 by root 5. So u is minus 2 by root 5, 1 by root 5, and then the second row is 1 by root 5, 2 by root 5, 1 by root 5, 2 by root 5, multiplied by sigma, which is square root of 10, 0, 0, square root of 40, and this will be multiplied by v transpose. V transpose is 1 over root 2, 1 over root 2, 1 over root 2, 1 over root 2, minus 1 over root 2 and 1 over root 2. So therefore this is what the solution for the second question, second matrix. If you solve all these three, if you multiply, you will end up in getting the matrix A. You can use the calculator and verify it. Okay. So let us go for an example of another triangular matrix where m and n are not equal, where number of columns and number of rows are not equal. Now we'll see how to apply singular value decomposition for a matrix which is a rectangular matrix which has 2 rows and 3 columns. Normally when we take a rectangular matrix of m cross n, you should know the dimension of the u and sigma and v transpose whatever we have. So when I have m cross n, then I will get a matrix u with m cross m dimension. I will get a matrix u with m cross m direction. I will get a sigma with m cross n, whereas n cross n is the dimension for v transpose. Okay, so therefore you should know what would be the matrix dimension before finding it. Okay, so u will be the dimension of u will be equal to the row of the given row dimension of the given matrix, which is 2 cross 2. Therefore for this particular problem we have a given matrix A is 2 cross 3 matrix. So we will get u to be equal to 2 cross 2 matrix and sigma will be of 2 cross 3 matrix, whereas V transpose when we find will be getting a 3 cross 3 matrix. Okay, so step by step let us solve this particular problem now. Always we all know that to find V we take A transpose into A, whereas to find U we will normally consider A into A transpose. Okay, so let us find V first and then we'll go to U. So to find V for this particular problem, so let us find V now. So to find V, sorry not V, it is V transpose. Anyway, at the end we will find out the V transpose. So let me take A transpose into A. So here A transpose will be equal to 1 0 minus 2 0 and 1. This is the A transpose that we get for this A, whatever it is been given, multiplied by A. So what is A? 1 0 minus 2 0 and 1. So now we will multiply these two values now and see what A transpose A we will get. So A transpose A equals 1 into 1 is 1 plus 0 into 0 is 0. So 1 plus 0 is 1. Now 1 into minus 2 is minus 2 minus 0. So minus 2. 1 into 0 is 0. 0 into 1 is 0. Therefore I will get 0 here. Minus 2 into 1 is minus 2 because minus 2 into 0 is 0. Therefore you will end up in getting minus 2. Now minus 2 into minus 2 is plus 4. Plus minus 2 into minus 2 is again plus 4. So 4 plus 4 which is equal to 8. Then minus 2 into 0 is 0. Minus 2 into 1 is minus 2. The third row is 0 into 1 is 0. Again 1 into 0 is 0. Therefore you get 0 here. 0 into minus 2 is 0. 1 into minus 2 is minus 2. 0 into 0 is 0. 1 into 1 is 1. Therefore 1. So this is the matrix A transpose into A that we get. Now our next job is to find out A transpose A minus lambda I, A transpose A minus lambda I determinant. So we will find out the eigenvalues now. So A transpose A minus lambda I equals 0. So therefore I will be getting 1 minus lambda minus 2 0 minus 2 8 minus lambda minus 2 0 minus 2 1 minus lambda. Determinant of this will be equal to 0. Now I think we know that popular equation for finding out the eigenvalues for a 3 cross 3 matrix, which is lambda cube minus trace into lambda square plus minus of diagonal elements into lambda minus determinant of matrix equals 0. So we'll use this now. Now what would be the trace here? Trace equals 1 plus 8, 9, 9 plus 1 is 10 is trace. Now minus would be determinant of, for 1 it is 8 minus 2 1. So 8 minus 2 1 plus determinant of, for 8, so for 1 we took 8, 1 minus 2 minus 2. Now for 8, this column and this row, it is 1 1 0 0, so it is 1 0 0 1 plus, for 1 you leave this row and this column, you will get 1 minus 2, 1 minus 2 minus 2 and 8. So therefore what do we get here is 8 into 1 is 8, minus 2 into 2 is 4, minus 2 minus 2 is minus 4, plus 4. So 8 minus 4 is 4, plus 1 into 1 minus 0, so plus 1, plus 8 into 1 is 8, minus 2 into 2 is 4, so which is again 8 minus 4 is 4. So 4 plus 4, 8 plus 1, which is equal to 9. Now this is 9 what we got. Now let us find out the determinant of matrix, which is A transpose into A, which will be equal to 1 into 8 into 1 is 8 minus 4, 1 into 8 minus 4, minus of minus plus 2 into minus of minus, which is plus 2 into, so minus 2 into 1 is minus 2 into 0, minus 0 into minus 2, so it is minus 2, so which is equal to 8 minus 4 is 4, minus 2 into 2 is 4, which is 0. So determinant of the matrix A transpose B is 0. So therefore I will be getting lambda cube minus trace is 10 lambda square plus minor of diagonal, which is 9 lambda, equals 0, because determinant of matrix is 0. Therefore if I take lambda common here, I will be getting lambda square minus 10 lambda plus 9 equals 0. So therefore one of the root here is lambda equals 0. So one of the root is lambda is equal to 0. The other two is we should take from this quadratic equation. So I can write this as lambda square minus lambda 9 lambda minus lambda plus 9. So this is the factors 9 and 1. So here I will take lambda common, so I will get lambda minus 9, and I will take minus 1 common, I will get lambda minus 9 equals 0. Therefore I will get lambda minus 1 equals 0 and lambda minus 9 equals 0. Therefore I got lambda to be equal to 1, lambda to be equal to 9. So these are the three eigenvalues which I got for this particular A transpose into A. Now after finding the eigenvalues, now let us go in finding eigenvectors for all these three lambdas. So I will take first lambda to be equal to 0. I will take this condition. Therefore A transpose into A minus lambda I for 0 would be equal to A transpose into A. So into X into V V actually into V. So A transpose into A minus lambda into V equals A transpose into A into V. That is what we get. Now what is A transpose into A, which we have done earlier? It is 1 minus 2 0. So let me take that. 1 minus 2 0. Then I have minus 2 8 minus 2. Minus 2 8 minus 2. Then again I have 0 minus 2 and 1, 0 minus 2 and 1 into V1 V2 V3. Now it is 3 cross 3 matrix, so we take 3 elements of V, which is equal to 0. Now we need to do further, so I'll say 1 into V1 minus 2 into V2 equals 0. Then I will say minus 2V1 plus 8V2 minus 2 times V3 equals 0. So if I divide this equation by 2, I will get minus V1 plus 4V2 minus V3 equals 0. Last one is minus 2 times V2 plus V3 equals 0. Equals 0. So here we should Okay, I think we can solve this matrix by doing row operation also. We'll do that. So I'll just write this matrix, like I'll just write this matrix separately. So where 1 minus 2 0, and I got this dividing by 2, I got minus 1 4 and minus 1 0 minus 2 and 1. So this is what I got. Now what I'll do is I'll take row 2 and I will add row 2 with row 1. This is the row operation which I'll do. You can do in this way. You can do row operation, reduce the matrix, and then you can also find out what is V1, V2, V3. So in that case, what will I get here is 1 minus 2 0. So here 1 minus 1, which is 0, because you are adding, minus 2 plus 4, which is 2, and then 0 minus 1 is minus 1. Then I got 0, minus 2 and 1 is what I got. Further, I'll take R3 and I'll replace R3 with R3 plus R2, and we'll see what do we get. So we get finally 1 minus 2 0 0 2 minus 1. So I'll add R3 with R2, so I get 0, minus 2 plus 2 is again 0, 1 minus 1, which is again 0. So this is equal to, so I got last row to be all equal to 0. So I'll just write these two equations, this into V1, V2, V3. So we normally say this has an infinite many solutions. That is the condition we have got here. But anyway, I'll take two equations which is formed by first and second. So I'll say V1 minus 2V2 equals 0, and then 2V2 minus V3 equals 0. Therefore here 2V2 equals V1. Similarly 2V2 equals V3. So if I say V2 equals 1, then V1 and V3 will be equal to 2. Therefore the final vector V1 which I have got here is, 2 1 2. So this is the first vector which we have got by this particular matrix. Now we'll find out what is the next vector, because of lambda to be equal to 1, lambda to be equal to 1. So now we'll see, we'll take lambda to be equal to 1, and then we'll see what would be the matrix that I get. So when I take lambda to be equal to 1, so here this is the matrix which we need to consider. So when I take lambda to be equal to 1, what is the vector that I get? So here A transpose into A minus lambda I equals into V equals 0. So here A transpose into A minus lambda when lambda equals 1 is 1 minus 1 is 0. Therefore I'll write 0 minus 2 0 minus 2, 8 minus lambda, 8 minus 1 which is 7 minus 2, 0 minus 2, 1 minus 1 again it is 0, into V1, V2, V3 equals 0. Now in the first and now minus 2 times V2 equals 0, and in the third row also you get minus 2 times V2 equals 0. Whereas the second equation is minus 2 times V1 plus 7 times V2 minus 2 times V3 equals 0. Now as V2 in first and third equation, as V2 equals 0, therefore we see V2 equals 0. Once V2 equals 0, we get minus 2 times V1 minus 2 times V3 equals 0. Therefore minus 2 times V1 equals 2 times V3. So V3 equals minus V1. So if V1 is 1, V3 is minus 1. Therefore the second vector V2 equals 1 0 minus 1, 1 0 minus 1. This is the second vector. Now let us go with the third vector, when lambda equals 9. When lambda equals 9, I think we got three vectors, lambda equals 0, 1 and 9. So let us go with 9 now. So when I go with 9, what will I get? So 1 minus 9, which is minus 8. 1 minus 9 is minus 8. Then we have minus 2 and 0. Minus 2 and 0. Then we have minus 2. Minus 2. 8 minus 9, which is minus 1. 8 minus 9, which is minus 1. And minus 2. And minus 2. 0, 0 and minus 2, 0, minus 2 and 1 minus 8 is again 1 minus 9, sorry, 1 minus 9, which is again minus 8, which is again minus 8. So this multiplied by V1, V2, V3 equals 0. So now you can either do row operations now for the second row. So what will I do? I'll take row 2 to be equal to row 2 to be equal to 4 times row 2 minus row 1. So I'll just replace row 2 with 4 times row 2 minus row 1. So what will I get? So I'll write first as it is, which is minus 8, minus 2, 0. Now 4 into 2 is minus 8, minus of minus 8, which is 0. Minus 1 into 4 is minus 4, plus 2, which is minus 2. Then minus 4 into minus 2, which is minus 8. 0, minus 2, minus 8. Into V1, V2, V3 equals 0. So therefore here we get three equations now, which is minus 8 times V1 minus 2 times V2 equals 0, whereas minus 2 times V2 minus 8 times V3 equals 0. So these are the two equations which we get. So therefore 2V2 equals 8V1. Similarly here also 2V2 equals 8V3. Sorry, minus 8V1 minus 8V3. Okay, so therefore you get V2 to be equal to minus 4 times V1, V2 to be equal to minus 4 times V3. Now I think if I substitute V1 to be equal to 1, then V3 will also be equal to 1 because they both are equal now. Therefore I'll be ending up in getting V1 equals V3 equals 1, whereas V2 equals minus 4. Therefore the third vector what we get, V3 is 1 minus 4 and 1. 1 minus 4 and 1 minus 4 and 1. Yes. So therefore the total V equals, right, all the three vectors that we have got. So let me take the first vector which we have got when V it was 0. So it is 2, 1, 2. So the first vector is 2, 1, 2. Second one is 1, 0, minus 1. And the third one is 1, minus 4 and 1. So therefore we'll try to take V transpose, which is equal to 2, 1, 2, 1, 0, minus 1, 1, minus 4 and 1. Now you take the norm of this row wise. So first one will get root of 2 2s are 4, 2 square, 4 plus 4, 8, 8 plus 1, 9, which is equal to 3. Second one is square root of 1 square plus 1 square, so you get 2. third one we will get is square root of 4 square is 16 plus 1 plus 1. 16 plus 1 plus 1, 18. Therefore, the final V transpose is equal to 2 by 3, 1 by 3, 2 by 3, 1 by root 2, 0 minus 1 by root 2, 1 by root 18 minus 4 by root 18 and 1 by root 18. So this is the final V transpose that we get. Okay, so I hope finding V is clear to you now. Let us go with finding out U. So U is found by finding out A into A transpose. So now finding out A into A transpose is what we need to do. So what is A? So A into A transpose, so let me take A. So A is 1, 0, minus 2, 1, 0, minus 2, and then 0 and 1. This is A multiplied by A transpose, which is 1, 0, minus 2, 0 and 1. So therefore this is equal to 1 into 1 is 1, minus 2 into minus 2, which is plus 4. So 1 plus 4, which is 5, 0 into 0 is 0. Anyway, 1 into 0 is 0, minus 2 into minus 2 is 4. 0 into 1, second row, first column, let us do that. 0 into 1 is 0, minus 2 into minus 2 is plus 4. 0 into 0 is 0, minus 2 into minus 2 is plus 4, plus 1 into 1 is 5. So we got 5, 4, 4, 5 is what A into A transpose that we have got. Now let us find the eigenvalues for this A into A transpose. So it is determinant of A into A transpose minus lambda equals 0. So therefore it is determinant of 5 minus lambda 4, 5 minus lambda equals 0, which is equal to 5 minus lambda into 5 minus lambda minus 16 equals 0. So 25 minus 5 lambda minus 5 lambda plus lambda square minus 16 equals 0. So finally what we get here is lambda square minus 10 lambda plus 9 equals 0. Now if you see this equation with the equation that we have got earlier while finding the roots for the V vector V while finding out, we got the same lambda square minus 10 lambda plus 9 equals 0. This is what it happens in SVD, where whatever the roots that you find out for finding out V transpose, then the eigenvalues what you find out for while finding out U. So the eigenvalues what you get while finding out U will be the eigenvalues that you get, will be the two eigenvalues that you get in V transpose while finding out the eigenvalues for A transpose into A. Okay, so while finding out the eigenvalues for A into A transpose, that value of eigenvalues will be same that you get even for the A transpose into A. So that two eigenvalues will be one of these two eigenvalues that we get in V transpose while finding out V transpose. So therefore I will be getting lambda to be equal to 1 and lambda equals 9. Now let us find out the vectors. Now vector U, let us find out after finding out the lambda values. So when is lambda equals 1, what will happen to the matrix? 5 minus 1, so it is 5 minus lambda 4, 5 minus lambda multiplied by u1 u2 equals 0. So when lambda equals 1, 5 minus 1 will be 4 into u1 u2 equals 0. So therefore you get both the equations in terms of 4, therefore 4u1 plus 4u2 equals 0. So you can easily say in this equation u1 will be equal to minus u2. So therefore when u1 equals 1, u2 will be equal to minus 1. Therefore the first u vector is 1 and minus 1. Okay, now let us find out when lambda equals 9. So when lambda equals 9, what will we get? So again 5 minus 9 is minus 4, 4, 4. Again 5 minus 9 is minus 4 into u1 u2 equals 0. So in these two equations, if you see, I'll get minus 4 times u1 plus 4 u2 equals 0, and second equation is 4 times u1 minus 4 times u2 equals 0. In both the equations you see u1 will be equal to u2 at the end. Therefore when u2 equals 1, u1 is also equal to 1. Therefore the second u vector is 1 and 1. Therefore the total vector u is 1, 1, 1 minus 1 is first one, 1 and 1 is the second one. Now we need to take the norm of u1. So norm of u1 will be equal to square root of 2. Similarly norm of u2 will also be equal to square root of 2. So therefore the total u will now be equal to 1 over root 2, 1 over root 2, 1 over root 2, 1 over root 2. So this is what u which we found for this particular question. Now finally we are ending up in getting sigma now. So sigma is 2 cross 3 matrix, because the dimension of sigma is equal to the dimension of the matrix given, which is a rectangular matrix which is given. So here the diagonal elements would be, this is first diagonal element and this is the second diagonal element. That's it. So we have 2 cross 3 matrix. This is what it is. Therefore what is d1 and d2? It is the common eigenvalues that you get for both finding u vector and v transpose vector. So there you got 0, 1 and 9 while finding out v vector. While finding out u vector you got 1 and 9. Okay, so that 1 and 9 will be, d1 and d2 will be square root of 1 and square root of 9. Therefore sigma would be equal to square root of 1, 0, 0, 0, square root of 9, 0, and we know square root of 9 is 3. Therefore I can ending up in getting 1, 0, 0, 0, 3, 0. Therefore you found sigma, you found u, you found v. So you will write the final term as u sigma into v transpose. You can replace u and v transpose with the values that I have found. So this is the sum. So this is the solution, final solution that we get. You write u and you write sigma and you write v transpose with the values that we have found earlier. Replace that u sigma v transpose with that, and that would be the end of this particular problem. I hope by this videos you people are clear about how to work on singular value decomposition, and the major benefit of SVD method is to find out the eigenvalues for a rectangular matrix where the number of columns and number of rows are not equal. So I have solved 3 problems here. I have taken symmetric matrix and I have found the SVD method. We have taken another matrix which is not symmetric but it is a square matrix and we have solved it. And we have taken 2 cross 3 matrix which is a triangular matrix and we have solved it. Okay. I hope this video with all these 3 problems you people are clear with SVD. You can watch the video again and again so that the concept will be much clearer to you. Okay.